This lesson is on finding asymptotes and holes of rational functions. First of all, let's review what a hole in a graph is going to be. A hole will appear when factors cancel. We're going to get the y value by plugging x into the new equation. We talked about this a little bit yesterday, but let's go ahead and do an example to review. This rational function right here has already been factored for you, and I see that there are some common factors. If the factor is in the numerator as well as the denominator, we can go ahead and cancel it out and simplify this function into x plus 3. Now let's talk about this function, because in the beginning the domain was all reals except we cannot use -2. I realize that the function has been simplified into something very, very simple, but I have to make a note here. -2 is still in the domain restriction. That means you are not allowed to use -2, even though that factor canceled, it's still not allowed. That means that there's a hole at -2 comma something. Now, how do you find the y value? By plugging x into the new equation. So -2 is going to go into the new simplified version, and that's going to give us 1. So this graph looks just like a line, except right there at -2 comma 1, there's going to be a hole. This is a line who has a y-intercept up at 3. It's going to be an uphill line with a slope of 1. So we have a line going uphill, and right there at -2 comma 1, there is a hole in the graph. That is when factors cancel. Now, vertical asymptotes are also breaks in the graph, but they do not appear when factors cancel. So vertical asymptotes, first of all, are vertical lines that the graph approaches. Okay, but never touches. Okay. So vertical asymptotes can never be crossed. To find a vertical asymptote, you simplify the equation by factoring. So first you factor the equation, and then you set the denominator equal to 0. Okay. To state the vertical asymptote, since it's a vertical line, since that's going to be a vux, make sure you say x equals. So let's look at a couple of examples here to see if we can find the vertical asymptote. Okay. First of all, I'm going to take this example number 1, and I'm going to factor the bottom into x plus 2, x minus 2, nice and easy. And then you're going to state the vertical asymptotes. I'm going to go ahead and write down the domain so we all know what the restrictions are. This equation is going to use all reals except you're not allowed to use plus and -2. Well, if there's no graph allowed at 2 or -2, then what is that graph going to have? Well, it's going to have a vertical asymptote. So here you say x is not allowed to be a 2. Where's the vertical asymptote? Well, there's one vertical asymptote at +2, and there's another one at -2. You can write those together if you'd like. If you do not have any graph at 2, there's got to be something there. All right, let's look at this next one. I'm trying to factor that bottom, but it does not. So the domain for this one is all reals. So that means we can use any real number we want. This graph does not have a break. So where is the vertical asymptote going to be if the graph never stops? Well, there is none. No vertical asymptote for that guy. And finally, this last one here, this one needs a lot of factoring, so let's go ahead and write f of x. I'm going to factor the numerator and the denominator. I'm going to give you a minute here to think about this. Okay, hopefully you have the numerator as x plus 3, x minus 3. The denominator factors into x plus 7 and x minus 3. So f of x can be simplified by by canceling out those factors into x plus 3 over x plus 7. Now let's go ahead and state the domain. The domain for this graph is all reals except, and you should look back at the beginning of the problem. There were denominator restrictions here saying that there's going to be no graph at -7 and x is not allowed to be a 3. Okay, so a couple things are going to happen. When factors cancel, that's not going to be a vertical asymptote. It's not there anymore. When factors cancel, that means it's going to make a hole. The hole is at 3 comma something. No graph at 3, that's because he's a hole. The other restriction that's still left, factors that are still left, are vertical asymptotes. So we have a vertical asymptote at x equals -7. Now we have to finish that hole. How do we find the y value for a hole? You take the x value and you plug it into the new equation. So go ahead and calculate that and tell me the fraction. 3/5. So what I recommend doing is factoring right away. Maybe writing the domain for all the denominator things that you see. When they cancel, they become a hole, and if they're still left, they become a vertical asymptote. Do you think you can have a hole and an asymptote at the same place? Of course not. You have to be one or the other. Okay, let's take a look at some more. Horizontal asymptotes are something else that a graph can have. Okay, and these are horizontal lines. Horizontal lines that can be crossed? What? They can be crossed? Absolutely. A horizontal asymptote does not have anything to do with the middle of a graph, but they tell the ends where to go. Okay, so I think we saw an example of this yesterday. Horizontal asymptotes only tell the ends where to go. They have no say-so in the middle of a graph. Okay, if the power of the denominator is greater than the power of the numerator. So what I like to say for this is, unofficially of course, bottom heavy. If the power is greater in the bottom, then the horizontal asymptote is real easy. It's always y equals 0. That's going to be super easy. If the power of the numerator is equal to the power of the denominator, okay, if they're equal, then you're going to have a horizontal asymptote y equals a over b. And where do we get those numbers? Yeah, those are from the leading coefficients. So horizontal asymptotes are super easy to find. Let's take a look at a couple of them here. I've got one example of a rational function, and I'm going to study the powers. I see a 2 and I see a 3. If the power is greater than the bottom, if it's bottom heavy, the horizontal asymptote is going to be y equals 0. So he's going to have a horizontal asymptote going like that. Let's look at these powers. I see a 3 and another 3. So the horizontal asymptote is, you take these leading coefficients, 2/3. So right here at the value of 2/3, there's going to be a horizontal asymptote. That helps the ends know where to go. To state the horizontal asymptote, since a horizontal asymptote is a HOI, you always write y equals number. Okay, here's another example. I'm going to give you guys 10 seconds to find the answer. Okay, did you notice the power here was 1 and the degree here was 2? And since this one is, quotes, bottom heavy, the answer is going to be real easy. Y equals 0. Done. Oh, that was easy. Okay, let's go ahead and mix it up a little bit here so we could see if you can find vertical asymptotes as well as horizontals, or maybe even a hole. The hardest part to doing these is probably getting the functions in factored form. Okay? So maybe what we'll do here is pause the video and go ahead and see if you can get this guy in factored form. The numerator does factor and the bottom does factor. So go ahead and pause it and come back when you're ready. Okay, what you should have gotten is 4x minus 3 times 2x plus 1 for the numerator. The denominator is 2x minus 1 times 2x plus 1. Okay, I'm going to go ahead and write a note here. I would highly suggest always state the domain first. Okay, I would recommend stating the domain because then you start canceling. Sometimes people tend to lose one of them. The denominator, the full denominator for this guy, he's going to use all reals except there's going to be no graph at plus or minus 1/2 for a variety of reasons. Now I noticed there's some common factors, so those cancel out. So r of x actually can get simplified into a nice little rational function here. Okay, and when something cancels, that's going to make a hole in the graph. So the factor that canceled gives us negative 1/2 comma something. The factor that's left, positive 1/2 is left, and that makes the vertical asymptote. X equals 1/2. So your domain said you cannot use positive or negative 1/2, but for two different reasons. Okay? How do you find the y value of a hole? You take this x number and you go ahead and plug it into the new equation. That's going to be some fun fraction work for you. And you should get 5/2. Now the horizontal asymptote, that's different. That looks at the powers. And you could go here to the original problem. I'm noticing a power of 2 and a power of 2. That means I would take these leading coefficients and say 8 divided by 4 is 2. So the horizontal asymptote must be y equals 2. Other people say, well, can we go ahead and look at the simplified version? Absolutely. The powers here are equal, so you could look at those leading coefficients and also get 2. Okay, so you could look at the large one or the simplified smaller one. Okay, let's do another example. Again, the challenging part here might be getting this guy in factored form. So I highly recommend pausing the video and trying this factoring here on your own. And come back when you're done. Okay, welcome back. Hopefully you have the correct factoring. 2x plus 3, x minus 4. The denominator factored, and we got 2x plus 3, but then it also can be factored further into x plus 2, x minus 2, so hopefully you got all three of those factors down there, because he was a cubic. I highly recommend staying in the domain before we go crossing part of them away. So this graph is going to use all reals except x cannot. There's going to be no graph at negative 3/2. There's going to be no graph at negative 2. There's no graph at positive 2 for a variety of reasons. These factors right here can cancel. So r of x can actually go ahead and get a lot smaller. That's going to be nice. And whenever factors cancel, that becomes a hole in the graph. So the hole is at negative 3/2 comma something. What about the ones that are still left? What are those? Yeah, those are vertical asymptotes. So x equals. This is a line at plus or minus 2. So here you say do not equal. There is no graph because that is there. Horizontal asymptotes, you're going to have to look at the powers. So if we look at the original problem, it's got more x's in the bottom. It's bottom heavy. Same thing here. X squared in the bottom. When you're bottom heavy, the answer is y equals 0. Here we have a nice fun fraction problem for you. Go ahead and put negative 3/2 into all the x spots and come back when you have a nice answer. Wow, that was some good work. 22 over 7. That's a pretty challenging problem there. Okay, we've got one more here. And again, the hard part is probably going to be the factoring, so go ahead and pause the video and come back when you are ready to tell me all 4 factors. See you in a minute. Okay, welcome back. Hopefully you got 4x minus 3, 2x plus 5. I think just looking at 4 and 2 and 3 and 5, maybe playing with them would be the fastest way to factor here. Down here, you may want to make an MA table, but hopefully you got 3x minus 1 and again 2x plus 5. Let's go ahead and say domain before we get rid of half of them. This graph is going to use all reals except no graph is going to be at 1/3 and no graph at -5 halves. Okay, let's go ahead and simplify him now so we have a smaller problem. R of x, r, the rational function is 4x minus 3 over 3x minus 1. When you cancel out a factor, what does that make? It makes a hole in the graph. So our hole is at -5 halves comma something. And the one that's left, there's no graph at 1/3, why not? Oh, because that one's a vertical, a vux, and x equals 1/3 line. 1 is a vertical asymptote, the other restriction becomes a hole. A horizontal asymptote, go ahead and look at those powers. When the powers are even, I like to look at the simplified version because, of course, it's more simple. And the horizontal asymptote is going to be 4/3. But you can look in either place. I recommend the small one, of course. And now for the most challenging part. Who can go ahead and challenge themselves and plug that in without a calculator? Maybe put some work here on the paper and then I'll look at it tomorrow. Did you get 26 over 17? Wow. Go ahead and try fun numbers like that. The test won't have anything that crazy, but if you can get that, then you're looking good. See you tomorrow, guys.